It's amazing.
So I know you said that you don't like to have to grade it whenever we send our homework in pictures.
Single pictures, yeah.
Yeah.
Mm.
And
Should I go visit?
I did that, I sent mine in like that, but if you still haven't graded it, I can just hand you the physical copy right now if you want.
What was it? Well, I thought I was caught up on your homework. I
checked
think
it, like,
I'm caught up.
yesterday or something.
What?
And then see the-
I thought I was caught up on your homework, but if I'm not, then give that to me. Yeah, I'll take it. I was convinced that I was caught up on your homework, and if I'm not, you have ruined my day.
So last one was- Oh.
But y'all didn't turn in homework 6,
Same,
right?
how many more drugs?
No, it was homework 7 you did not turn in yet. Right. You did turn in homework 6, and I did grade that one.
Everything is graded that we turned in. On time.
Except maybe
Okay,
Charlotte's.
yeah, my homework 6 isn't, so. Unless you just want to give me a 0, I hope that's not the case. But,
Maybe I did.
here's the physical copy, if you like that. I will take it.
Wait, 6.1.
No, this is still the contrapositive
the
worksheet or
worksheet.
whatever. Yeah.
Would you like a stapler? Got this one.
Yes. Sorry, I threw Charlotte's stuff in the floor.
Had to crawl.
I mean, it wasn't really the greatest, but it wasn't that bad. I do remember putting on there that one of them.
That's the one that you, we did some of it in class, remember?
Yeah.
And you hadn't sent it in yet, and I told you,
I
send it
I like
in.
emailed it in the middle of class.
Okay,
Like
maybe
right
I,
as you said that, I like
Okay.
pulled out my phone and did it.
okay. Thank you.
The important thing is I printed it on time, sort of.
Maybe, maybe. I had already graded everyone else's, so seems like maybe not.
Yikes.
It was
Okay,
due Tuesday night or whatever. And I got it in before Tuesday.
no, it wasn't.
Was it?
No,
Dang.
you gotta start writing the dates down, Charlotte.
No.
Because I thought, man, it's interesting that Charlotte just decided not to do this homework.
Well, then again, I did think you were gonna be in class. I was like, oh, I'll just return class. And then you weren't there. So I blame this on, you. so
You're
I
gonna
don't
blame
go-
me?
Oh, dang.
So I can sleep at night.
Fair, okay.
Oh, jeez.
Blame it on my child, that's fine.
Children.
I have like several homeworks that I have graded that are on paper here. Y'all remind me to give those back to you today, because I don't want to carry them around anymore. And your tests, but I'm not gonna give them to you yet. We'll
Oh,
do that
no.
later.
I'm very nervous about that.
I just put the grades in Blackboard, so you don't need to be nervous. You can just look at it. There, it's in Blackboard now. What'd you say?
By later, do you mean today or?
Yes. No, I'm just gonna put them right there just to taunt you and then pack them back up at the end of class and leave. That's sort of how I roll. I probably will forget though, for being totally honest, so. That's why I put him there, so I would remember. Okay, yeah, you remind me. Okay, I am gonna make sure I'm screen sharing in Zoom. I am not. I gotta remember to download these videos and post them in YouTube now that we're using Zoom and they'll actually have sound. Marina, was there no sound at all?
There was like sound, but it was so, like I turned everything up and I still couldn't hear it, like, it was like a whisper.
Why? Why do we think that is?
I don't know.
Why does Teams suck so bad?
I went back and watched a couple of them. It was like,
Yeah, like, it would like either like say
It would
like
be
the
like-
words and then
yeah.
not, or it would be really like really quiet. That I can hear.
Good,
Yeah.
excellent. Well, we're using Zoom now, so things should be right, unless I'm muted, in which case won't be. I'm not muted, so we're good there. Okay. We are looking at this still in your note packet. We're on page 26 of the note packet there. Your note packet number 2. We have a couple pages left to get through here, and then we're going to start the next one. So the Cartesian product is the first thing that we want to talk about today. The Cartesian product is a thing you are familiar with, you just don't know what you're familiar with. It's like sort of everything else we're doing here, it's stuff you know, but we just make it more detailed, yeah? So, the Cartesian product, you guys know this thing, you have been doing this for a really long time. Remember what this is called? The Cartesian plane. Because it's a Cartesian product of the reals with the reals. These are ordered pairs X, Y, where each one is a real number. Yeah. This is all possible ordered pairs X, Y. So the Cartesian product of two sets, the real numbers are a set. The Cartesian product of two sets is all of the ordered pairs, where the first entry in the ordered pair is from the first set and the second entry in the ordered pair is from the second set. So symbolically, you're looking at A cross B as a set of all A, B, where A is in A and B is in B. Again, you're already familiar with the Cartesian product because that's ordered pairs in the XY plane. The Cartesian plane is because of the Cartesian product of the reals crossed with the reals. Okay, so let's do this. I think that this was one of the questions that we were maybe confused about whether or not you were supposed to have been able to do it yet on the homework for chapter 6. This was a no, you weren't supposed to be able to do it yet, but this is pretty straightforward. You're gonna take this and like every element in A and put it with the elements in B as ordered pairs. And then just do this for all of them. It's really hard for me to write parentheses and commas next to one another. I'll do my best for you. Okay. So notice how I've taken every, like the first element in A, put it with both elements in B, second element A, put it with both elements in B, third element in A, put it with both elements in B, fourth, put it with both of them. Any questions about that? Sort of tedious, but it's not difficult, right? Yes. Marina, I did actually look through your last page quite a bit on your exam, and I enjoyed looking through it. The chaos that was your mind on Thursday afternoon was pretty fascinating, but there was some really good stuff in there. So
I don't know how you even could like read anything.
my eyes are pretty trained to find the right thing, right? So I did, and then I looked around it. I was like, yeah, okay. Okay, so on this one, you're doing it the other way. So the first element will be from B and the second element will be from set A. Nope. Again, it's tedious, but not difficult. ZA, ZB, ZC, ZD. We are the French peas. I have to read that book to my children.
Why?
Well, it's a VeggieTales book and it has like all the different characters about how God made us special. And the French peas speak, you know, but it's all the different characters. So I got to use different voices for all of them because, you know, we are the French peas. 1, 2, 3, 4, 5, 6, 7, 8. I won't do that this summer when I'm in France though. So I won't pretend to have a French accent. Correct. Yes. Okay. So here we have A cross B and then B cross A. Notice in the first one, it goes in one order and the second one is in the other order. This is a Cartesian product of two sets. Again, not hard. Are we doing okay? Yes. All right. Looking at both of those, you can see that they have the same number of ordered pairs, right? And that number is 8. Yeah, so you can make a guess perhaps if remember that this you don't remember. I know that most of you don't remember. These things, this is the cardinality is I couldn't come up with the word. The cardinality, which is the number of things in the set. So if the number of things in A is in this case M is 4, and the number of things in B is N, in this case N is 2. how many things are in A cross B? M times N, yeah. So the number of things, remember those absolute value bars around a set is the cardinality of the set or the number of things in the set. So the number of things in A cross B is the number of things in A times the number of things in B, or M times N. Okay, cool. Questions, comments, anything you got?
Are we actually going to push the X to symbolize multiplication?
We're not gonna really do it at all. I don't know, whatever. If it's two sets, it's the Cartesian product. If it's two numbers, it's a actual product. If it's a vector, it's a cross product. I mean, context is everything, math, right?
Sure.
It is. That's sure is not the right answer. It is, yes. So, right, if it's two numbers and there's an X between them, that's just regular multiplication. Okay. So number 17 here, exercise 17 here. What? Have we been counting the exercises? Anyway, we have these three sets, A, B, and C. We're going to prove if B is a subset of C, that A cross B is a subset of A cross C. Cartesian product. Yeah?
Okay.
Okay. So we're going to do scratch work here because it's important. Shoot, I don't remember what color I'm supposed to use to do this. Green.
Green. Yay. All right.
Okay, so we have, what we know is that we have sets A, B, and C. And we get to assume that B is a subset of C. What are we trying to show is the real question here.
A cross B is a subset of A cross C.
How do we prove that a set is a subset of another set? What does it mean to be a subset?
Find an arbitrary element.
Pick
in
one,
A.
not find one, just pick one. Yeah. Mhm.
Pick one.
In the set on the left.
And then prove that it has to be in the set on the right.
Good, yes. So we're picking an arbitrary element in the set on the left. So we're gonna pick, we're gonna call it, sorry, pause. What do the elements in A cross B look like?
Order pairs.
Yeah, so we're gonna and I'm gonna call this Charlotte, I'm gonna call this AB. Because why? Because the little ones go inside the big ones, right? So, you know, we're gonna let this thing be an element in the set A cross B. Notice that the Cartesian product is a set of ordered pairs, so it is itself a set. Yeah? It's a set, that's the Cartesian product of two other sets. Okay. So we use the element notation there. So AB is an element of A cross B there. Now, what do we want to do?
We want to show that it's also in A cross C.
Yeah, we want to show, the goal here is to show that AB is an element in A cross C. Okay, what does it mean for AB to be an A cross B? If this element is in this set, what does that mean? Yeah, yeah. So then we know that A is in A and B is in B. What else do we know now? Yeah. Since B is a subset of C, little b has to be in big C.
What, okay, so why did we get to?
That's the if part, yeah.
I was gonna say, why we get to assume B? Or a subset of C,
I
but C is
just
right now.
answered that question because it's the if part of the statement, yeah, it's the P part that we get to assume. Okay, so that means that A is in A and B is in C, so AB is in A cross C. There's a lot of letters shouted at you. but we've done the thing we were supposed to do. Kaylee's not here. Kaylee doesn't ever write proof at the beginning of a proof. She missed a lot of points on that on the test because I was trying to be nice when I made the rubric and put 1 point for a proof and 1 point for a box on every question, thinking it would be helpful. Where is she? Where is she? Okay, that was Batman. Yeah, that was a good Batman voice. No, that was Christian Bale Batman. No, it was good, right? I think so.
Sometimes you can do it as a-
You what? You thought he was in the room? Good, Logan. Thank you. Okay, so we are gonna let A, B, and C, I bet she won't do that anymore, B sets. And assume B is a subset of C. We are gonna let little a b be an element in A cross B. My little element symbol is so teeny tiny. Yeah. It gets weird if you don't with sets like this. It gets super weird if you write is an element of. It's real ugly. And we're gonna get to a point where we're gonna just write like A, B, or N, Z. Two, probably, because our proofs are gonna be they're gonna get longer, and we're gonna need some.
So wrong.
I know. But this, like with the set stuff, it's like this, I mean, yeah.
It just feels wrong.
I'm glad that it feels a little wrong. That means you're learning, right? It does. I don't know what I'm doing anymore. We're letting A, B, B, and A cross B.
Okay.
Okay, that means A is in A and B is in B. Since big B is a subset of big C, we have little b is in big C. Then observe, notice,
Notice.
because I'm going with because A is in A and B is in C, we have A, B is an element cross C. Wow. Therefore, A cross B, subset of A cross C. Whenever B is a subset of C, if you wish to go on. Questions? Anything? Feels okay?
I know that we hadn't really like gone over like proofs with sets. but
We
I
did
looked-
one.
We did one, but like,
Mhm.
I looked at the homework and I was very confused, like thinking through it.
Mhm.
What's like a thing that you can do?
We're gonna do a whole bunch more. Could you just hold on to your questions till then? All of these left are proofs of subset proofs.
Okay.
And then hopefully it'll make more sense. See, you would be confused since you did things we weren't ready to do yet. I'm not mad at you for working ahead, but don't ask me about it till we've done it. Okay, so we will almost always be proving that a subset things are subsets or that they're equal, which is, again, it's just two subset proofs. Prove it's a subset this way and it's a subset that way. Yeah. Proving subsets, you're gonna pick an element in the set on the left, show it has to be in the set on the right. It's an arbitrary element. Don't pick like 2 if it's the integers, just pick X. You're gonna use definitions to do this thing. You can use examples in Venn diagrams if you would like to help you convince yourself that things are true, but don't write those as proofs. Cool. Cool, good. All right, now this is a weird one. This notation's strange. But that's the double complement there, the complement of the complement. That's what that little C was on your test too, or a little tick mark. Yeah? What does it mean to be the complement of a set? Yeah, it's the stuff that's not in that set. So if it's the stuff that's not and not in that set, it makes sense that it would be the stuff in the set, right?
Yeah.
The double negative makes a positive, yeah?
Mhm.
Okay, so we're gonna prove that these two sets are equivalent. We haven't done an equal to proof yet, so I'm gonna sort of. I don't know if I'm actually going to do any scratch work, but whatever. Going this direction, we're gonna show that the double closure is a subset of the regular set. And then going the other way, we're gonna show that A is a subset of the double closure. And then we get that they are equal. All right, so we're gonna let A be a set. We will show a double closure complement, sorry, is equal to A. First, we're gonna do this thing first, right? This is our number one activity here. That looks plus sign, is a 1. This is our number one thing we're gonna do. So we're gonna pick an X that's in a double bar thing. This means that X is not an element in the complement of A, right? That's a single one now. If it's in the double complement, that means it's not in the complement, right? Think about it like this, right? If it is in this guy, that means it's not in this one, correct? Yeah. Because that's what the complement of a set is, it's the stuff not in it. So the complement of, like, say this is B, right? The complement of that means it's not in B. So the complement of this guy means it's not in A with a single bar. And if it's not in the complement of a set, that means it's in the set. So we've done the first thing, that A double complement is a subset of A. That's kind of weird, but are you following it? It is one of those things where, again, if you explain it with, the more you explain something that's simple, the harder it sounds. So I'm gonna just stop.
What is this, like, proof by cases?
It's an if and only if proof, it's back conditional.
Okay.
Way.
Yes, it's two different proofs smashed into one with a beginning proof thing and then a box. But each one independently is its own little baby proof. So this is a super proof. Yeah. Okay, so we're gonna let X be in regular A. This is just the same thing backwards. So then X is not an A complement. Thus, X is in the complement of the complement. So A is a subset of the complement of the complement. So then you would say something like, since A double complement is a subset of A and A is a subset of A double complement, we have shown A double complement equals A.
And then why do we have to go both ways?
Because it's an equal to proof. You can't just show it's a subset. That show. It's the same question you just asked a minute ago. Well, yeah, this equal to thing, this is basically saying, prove that this is a subset of this and this is a subset of that, right? The only way that they can both be less than or equal to or contained in the other one is if they are equivalent. So you get the like two proofs that happen because you're proving each of those things separately. What? Oh, mhm. All right, other questions, comments about that? Does that look okay? Yes? We have another equal to thing here, Ruth. So again, we're gonna be doing two proofs, subset each way. What we want to show when we do this is that A union A intersect B is a subset of A, and that A is a subset of A union A intersect B. So this is going to be our like forward proof. The biconditional, right, is the arrow going both ways. It's not P implies Q, it's P if and only if Q. I don't know how to explain that differently, sorry. Thinking about this as like a Venn diagram might be helpful. If this looks like it's complicated, but it's really not. If this is A and this is B, I mean, and if we could just draw a picture to be the proof, that would be great. What my discrete is intro to mathematical proofs professor always said was, a picture does not a proof make. Okay. But then I became a topologist where pictures do make proofs, so oh well. But in this case, a Venn diagram is not good enough. But looking at this, you have A union with A intersect B. So this is A intersect B. If you union that with A, obviously, that's just the set A, right? That's obvious. I hate it when I say things like that and then people are not nodding. I'm like, crap, was that not obvious? And did I make people feel silly? I hope not. But A union with A intersect B is just A, because, okay. All right. So what we are going to do is prove this both ways. So we're going to do this the same kind of way. A lot of Ruth, to answer your question, maybe more, a lot of these kinds of proofs, when you're inside of it one way, you might have a proof by cases sitting there. If it's like a union, then it's in this thing or it's in this thing. So you're like proof by cases would happen that you, okay, well, it's in, what if it's in this one? And then what if it's in this one? All right, so let's do this proof. We are going to let A and B be sets. We will prove A union A intersect B is equal to A. Again, we're going to do this two ways. So first, we're going to let X be in a set on the left. So X is in A union A intersect B. So what does it mean for an element to be in a union of two sets?
X
It's in one or the other, yeah. So, right, so then X is in A here, or X is in A intersect B. Either way there, though, it's pretty clear that X has to be in A, right? Because if it's in A, it's in A, great. If it's in A intersect B, then it's in both A and B. So in either one of these scenarios, it's in A. So we have shown that A union A intersect B is a subset of A. And then going the other way, we're gonna let X be in A. Look at this, y'all. Obviously,
Oh, no.
X is in A union A intersect B. This. A is a subset of A union A intersect B. The obviously thing there is, you know, it's in, if it's in one of the two sets, it's in the union, like you don't have to do any work, right? Yeah. Okay. Okay, so then you would say something like, since we have shown A union A intersect B is a subset of A, and A is a subset of A union A intersect B, A equals A union A intersect B. Questions? Questions? Anybody got questions? We good? I told Ruth this, I did not tell y'all, but when I was making the key for your exam last week, I had to stop and take a break because my hand hurt. I was like, but I wasn't doing any thinking, right? Surely y'all were stopping, pausing to think. Yeah, I was just like, right? Because obviously, because I made the test, I should be able to take it very quickly, which I was trying to do, but then I couldn't because my hand hurt. I had to go do something else for a while. I was like, I cannot make letters anymore.
Mine didn't hurt too bad because most of the time I was just like this.
You also, you write very,
Together.
it's light, you know, there's no aggressive, like, it's very just like, I imagine that you're just doing this as you write proofs. Never picking up your pencil, just,
I am very aggressive with my writing.
yes, yes. Mhm. I'm sure you both, your hands were hurting, and Marina's did, not because of anything that any way she writes, but because of how much she wrote. Marina rewrote 2 proofs the same way that she wrote them the first time, and correctly both. I don't know why you rewrote the proofs. Do you know why
They
you?
were really messy. Like,
Oh yeah, I don't care.
I had to like rewrite something if I was writing wrong.
Yeah, oh yeah.
So yeah.
She wrote a bunch of the proofs twice, so that's why her hand hurt.
My grammar.
I didn't have time for
Your what?
that.
My grammar was not good. so I had to
Whatever.
redo it.
You know,
These grammar
when English isn't your first language, I do have to sort of take that into consideration when you're writing full sentences in English.
Oh, I don't have an excuse.
I don't have that excuse either. Well, I mean, technically, yes.
Marina does, the rest of us, no.
I mean, I didn't speak English.
Marina's grammar was better than some of ours, so,
Oh.
which is, not surprising at all. Because the American education system is lacking.
This just makes me like more worried about the test.
You want me to tell you what you made out loud right now?
Sure. Well, wait, only if it's like above an 80.
Do you want me to tell you number grade or letter grade? I don't remember the number.
Okay, letter. Why'd you give me an option?
I was gonna guess, but then what if I guessed wrong?
If only if it's like a B or an A, you're allowed to say it.
I wouldn't have offered if it wasn't. So
Okay,
you're good.
I gotta see.
that gives me hope.
I gotta see on mine. So. Better than a failing
Improvement's good.
grade. Better than a failing grade.
My mom always says C's get degrees.
Yes.
I don't know about C's getting math degrees.
I'm not sure about that.
I'm just kidding. I'm joking. Let A and B be sets.
Oh no, I go cheating.
This one's real super easy. If I were to put a set proof on a test, you want me to put this one, but I won't. So,
What?
well, I mean, it's
No.
silly, right? It's silly. This is silly. X is in A intersect B. Obviously, X is in A. Right? Is it obvious?
Yes.
If X is in A intersect B, then X is in A and X is in B. So X is in A and A intersect B is a subset of A. And that's that proof we done.
Wow, that's it.
That's what I'm saying.
Speed round.
That's pretty good.
How fast can we get these proofs done?
Well, the others are gonna take more time.
Ah, dang it.
How are we doing on time? I forgot my watch today. It's awkward.
2:41.
Oh, we're doing great. We are gonna get to start the next packet. That's exciting.
I'm excited.
How much homework are due on all this time today?
I have no idea. You tell me.
6.2, 7.1, 7.2.
They're not due till Thursday. Whitney says they're not due till
Yeah.
Thursday.
They're not due
I
till
do
Thursday.
think that y'all should turn in your chapter 6 homework before you leave for spring break.
Chapter 6. Oh.
Yeah, homework 7. Written homework 7. Charlotte, are you listening?
I had every intention to hand it to you.
Homework 7
Oh,
on
that one, okay. Yeah, I have every intention to hand it to you
on Thursday.
on Thursday.
Okay, the homework 7, which is over chapter 6, I would like for you guys to give me before you go on spring break. Yeah,
Bet.
is that Saturday, Friday?
Yeah.
Sure.
That's my end.
Whatever. So if you want to turn it in, if you're gonna turn it in, do it before you leave campus Friday. Actually, do it before I leave campus Friday.
What time do you leave campus on
One-
Friday?
1:20.
That's what we were doing after math on Friday.
Before spring break? Surely we are not.
Really, I thought we were.
Whatever, if I'm after, turn it in by 1:20 on Friday. Who cares if I'm here after that? Turn it in by 1:20 on Friday, email or it on paper to Julia or to me. And if you turn it in by email, make it one thing, one single thing.
I felt bad when I got your email back for like the 6 different.
Oh, yeah. I also felt bad because then I have to like get it out a piece of paper and keep track of how many, points you've missed on each page that I've graded, and that's super annoying. But
I don't have
just
that problem.
one PDF. You guys are computer science majors or math majors or cybersecurity majors, which means either you're good problem solvers, math people, or you're good with computers. So you should be able to figure out how to make a single PDF, right?
There's an app
Genius Scan,
Cam scanner.
There's an app, it's,
Genius Scan works, or Cam Scanner, or the Notes app on an iPhone. Any of them will do batch scanning from like pictures, and then
I do have an app. I just didn't use it.
that makes me angry.
Dr. Mr. Thomas didn't like the app because he said that he didn't like the way that it looked with the
it's because it merged all your
like,
words.
yeah, with my words together, yeah.
You just made one giant black line on the paper.
Maybe you should get a different app.
Okay.
I don't want all your words to be one giant black line either.
Well, that's all he writes.
That's fair.
It's all squished together, so it made all the black lines connect. So it's hard to read.
That's fair. Get a better one. Okay. On this one, we are going to show that these two sets are equal, which means we're going to do two subset proofs. Yes, right.
Sure.
Ruth, are you being serious?
I'm just looking this.
When you see an equal to thing with two sets, you have to do two subset proofs. Show it this way and this way. Right, think about this with numbers, like 2 is less than or equal to 3, yeah? But 3 is not less than or equal to 2. So that thing only goes the one way. But 3 is less than or equal to 3, yeah?
Mhm.
And 3 is less than or equal to 3, right? It goes both ways there. You can't tell us which the order, but it did. So that's like if A is equal to B, that means that A is contained in B and B is contained in A.
Oh.
And that's the only way you can show that two sets are equivalent, to show everything in the set on the left is everything in the set on the right, and everything in the set on the right is in the set on the left, right? You have to show it both ways. So anytime you see an equal to with sets, to show that they are equal, you have to do two mini proofs. One super proof. Yeah, every single time. So the we're going to show that A union, and remember that line thing, that's a B toss A, that's set subtraction. If you want to write it as B minus A, you're fine, that's fine too. We're going to show that this is a subset of A union B, and we're going to show that A union B is a subset of A union B toss A. This proof gets kind of weird in the weeds, but we'll get it. Okay, so we are going to let A and B be sets. We will show A union B toss A. Gosh, what is happening to my writing? A union B toss A is a subset of A union B. First, let X be in A union B toss A. What does that mean? We're doing a subset proof, remember, so we're gonna pick something over here and show that it has to be over here.
Why don't we do A?
What are you talking about? What do you mean?
Put A as an element of A.
Oh,
Okay.
sure.
Okay, it's just X is.
Because B is floating around too, and it's sitting in this union. I don't know that it's in A, in just A. So I don't want to confuse myself, mislead myself, thinking that I know where this thing belongs, because I don't. I know it's in the
Okay.
union of these two sets, but I don't know which of those parts it's in. Right, so calling it one of their names doesn't necessarily make sense here.
Okay.
Okay, so,
At the beginning of the proof,
yeah,
it has, it should be the equal sign.
thank you. We will show it's equal by first showing the subset thing. And then the other subset thing. Thank you, Whitney. Okay, so we have X is in A union B toss A. That means that X is in A or X is in B toss A.
Well, is it true that if then the B toss A is anything in B but not in A, right?
Correct.
So X had come from B, not A. Right?
No.
No?
X either comes from A or from B, so X is A union B. But this happens because X is in A or X is in B, toss A. Okay, so if X is in A, we're done. X is in A union B. Yeah.
Okay.
If X is in B, this is where you get cases inside of your one direction. So I distracted myself so bad there. If X is in A, then X is in A union B and we're done. If X is in B toss A, then X is in B and X is not in A, but X is in B. That's not a B, that hurts that. Since X is in B, X is in A union B. So that like, this line is basically like your case one in this union thing. So it's in the union, it's one of these two things is happening. If the first thing is happening, we're fine. If the second thing is happening, we're also fine, because if X is in B toss A, that means it's in B, but it's not in A. So it's in A union B because it's in B. Yeah? All right, this A union B toss A is a subset of A union B. All right, and then we got to do the subset proof the other way. So we're going to let X be in A union B now, which means X is in A or X is in B. If X is in A, then X is in A union B toss A. If X is not in A, then X is in B toss A. So X is in A union B toss A. Does that part make sense? The situation, if it's in this union, then it's either in A or it's in B. So really we get, is it an A or is it not an A? If it's an A, we're done because it's in this part of the union, so it's fine. If it's not an A, then it has to be in B, but it's in B and not A, so then it's in B toss A. Yeah? Does that make sense? If it's not in A, then it has to be in B, but further than that, since it's not in A and it's in B toss A. Yep. And then since it's in one piece of this union, it's in the union. So we're done. Okay, so we are getting here that A union B toss A is a subset of A union B, and A union B is a subset of A union B toss A. So they're equal. Oh, since we don't need that, okay.
Do we need to write the, like, this? A union B.
Oh, probably should have, yeah. Thank you. A union B is a subset of A union B toss A. Thank you. Oh, since it's a subset of that, and that's a subset of that, then they're equal. I would like to be done writing set proofs for today.
Are you supposed to rest of
So
them
I
on?
will post 5 and 6 and 7 on the internet for you. Okay, well, I'll probably forget. You'll remind me, Ruth. Somebody remind me and I'll post those for you. What I wanted to talk with you through are these things, because these are kind of fun little puzzles. So, these examples are things that we're going to prove to be wrong. So this is like saying for all sets A, B, and C, if A union C equals B union C, then A equals B. To show that for all statements false, we're going to find a counterexample. So we're going to come up with sets A, B, and C where we break this. Yeah, so we're going to come up with sets where we're going to come up with sets both, all three, A, B, and C, where the union of the pairs here is equivalent, but A doesn't equal B. Okay? Okay. What do you want the union of the sets to be? That's the best place to come up, the best place to do this.
Something like 1, 2, 3, 4, 5.
Sure.
It's simple.
So we want A union C to equal B union C. We're gonna let Charlotte picked for this to be 1, 2, 3, 4, 5. That's also B union C. So we want those unions to be equivalent, but we do not want A to equal B. So how can we come up with sets A, B, and C where their union is that thing we're looking at? Like A union C and both and B union C equals 1, 2, 3, 4, 5. However, A and B are not the same.
When we do the union, we remove the duplicates, right?
Mhm.
So does that mean like one could have a duplicate that's in the other?
Mhm.
If A has 5, but B doesn't have 5.
Okay, so what if we make A 1, 2, 3? What could we make B? What could we make C? What does C need to have to make A union C 1, 2, 3, 4, 5? At least 4 and 5, right? We should make it have more than that, or there's no way we can come up with a B. Actually, we could, because we could make this 1, 2, 3, 4, right? That works, doesn't it?
Yay.
So we have these sets A, B, and C where A union C, B union C are both 1, 2, 3, 4, 5. However, our A and our B are not equivalent. There are lots of ways to do this. This is not the only way. I have mine stacked, my example. I have A is 1, 2, 3, B is 1, 2, and C is 3. Anyway, okay, so there is a counterexample to that for all statement. Here we got this other one. If their complements are equivalent, then their union is empty. What? So we need a universal set to start with, right? And then we need to come up with two sets whose complements are the same, but whose union is not empty. Hold on. Ruth, what time is it?
But it doesn't equal an empty set?
Yeah, because we're trying to negate this, right? So P and not Q.
Okay.
Well, like the complement is just like what they don't have, right?
Mhm.
So just because they don't have stuff doesn't mean they're empty. If they could have stuff.
They each could have stuff, yeah, but you want their union to not be empty. Which would
Okay,
mean
so
they
you
each have
want
stuff,
thing in
yeah,
common? They just be the same set.
yeah. Yes. They are just the same set, so their union can't be empty. Yeah,
So.
why do they have to be the same set? Because the stuff that's not in them is the same, so the stuff that is in them is also the same, right?
Yeah.
So if we let our universal set U be, what do you want? 1, 2, 3, 4, 5 again?
Sure.
It's excessive, but it's fine. If our universal set, huh?
I'm showing it to 1, 2, 3.
Yeah, that'll be fine. So if our universal set is 1, 2, 3, 4, 5, A is whatever, it's just 1, and so is B. Then their complements are the same, right? It's 2, 3, 4, 5. But they're not, the union's not empty because the sets are the same. Bless you, goodness, y'all. A union B here is a set containing 1, so it's not empty.
We'll just make A and B equal to everything that's in the universal. And their complements would be nothing.
Empty.
So it has to be both be 1, 2, 3, 4, 5. Is that the thing, or how's that?
Yeah, I guess you could, that's an example where this would be true, right? Is that
Yeah.
both of your sets are the full
Oh.
set, right?
Yeah.
If both of your sets are the full set, then their complements, no, if they're both empty. Yeah, then their complements would be full, and then their union would be empty. Yeah, so that's an example where this does work. We wanted a counter example where it doesn't work. Does that make sense?
Mhm.
Yeah, okay. All right.
So, okay, I do have a question now that we've done the question and all that, is the empty set, the cardinality of an empty set is 0, right?
The cardinality of the set containing the empty set is 1.
Yes, that makes sense, but an empty set.
The actual empty set has nothing in it, so it's got no elements in it, so its cardinality is 0.
Okay.
Y'all are gonna do, I think in that homework, you do like the power set of the set containing the empty set or something. Things get weird, and then you're doing the cardinality of those things. It's, just keep track of it. If it helps you to write it as like actual empty braces instead of writing it like this, do that. Because you can see when you're looking at the empty braces that there is actually nothing in there, right?
Because I went back and did some studying for the test, I went back and did the cardinality of everything on there. And we didn't ask for that.
Mm,
I did it, and
mhm.
there was one that was an empty set, there was nothing in that thing, so it's like, oh, the cardinality, that's easy to write. But I assumed that, so it's like, I better check and make sure it's the correct answer.
We would like to come up with sets A and B where A is not a subset of A intersects B.
So it would be 1, 2, 3. 5, 6, 7.
So A intersects B is empty here. So clearly 1, 2, 3 is not a subset of that.
Would this also work if B equal 1?
Yeah.
And then.
Yep.
With extra steps in.
I did it as A was 1, 2, and B was 3, 2, 3. So their intersection is not actually empty, but still not a subset. Or A is still not a subset of it. Okay, it is a subset of A. That works the other way around, right? Okay. That's that note packet. You got any questions? Any other questions? So I'm gonna tell you guys this right now. Thursday, either come with your homework finished or come with questions. You should not walk out of here Thursday without having started that homework, because if you have questions, it's too late to ask me. The reason it's not due until Friday is so that you have time to ask me questions. Yeah? The point of doing the homework is to understand the material. Yeah? Okay. Making sure we're all on the same page. It's not just to get a grade, it's to understand anything like this. Carry around the extra copies with you. I don't think this one's longer, Charlotte. No. This one's 31 pages, this one's 32.
1 page longer.
Okay, thank you, Ruth.
Sorry.
Appreciate you. That's really necessary.
Actually.
Actually.
The people who have to be most correct irritate the crap out of me. Sorry.
Sorry.
It's fine. I'm trying to teach my son to not be that way. Give me a minute, bud. 1, 2, 3. I am gonna lose it. You need to stop doing that right now.
Tell him, give you like 4 days. And then have him count along. I'll keep him occupied for so long.
He argued yesterday was my daughter's 4th birthday, and he argued so hard on Sunday about whether her birthday was 1 day away or no days away. Shut up, just shut up. It doesn't matter. Is it today? No. So there's still more time. So we can't say it's 0 days away. I don't know, but do we count the day you're on? It doesn't matter. It doesn't matter. Let's stop talking about it. Let's stop worrying about it. It is.
Interesting
23
question.
hours? Yeah. It's not
Correct. I understand. But the fact that he could not just let it be. He's 5. What am I gonna do when he's 16?
That's a future, that's a problem.
Sad, but true, probably. Oh, man. Okay, we're trying to teach him like, and his sister says something wrong and he'll be like, that's not it. Just, she's 4 now. Leave her alone. Just leave her alone.
She's 4. Leave her.
It's not your job to correct her anyway. So we are gonna start talking about functions. And you're like, I'm pretty good with functions, Dr. Thomas, and I bet you are.
I know.
Basically, again, this is something that you think you know, and I'm just gonna add a whole bunch more stuff to it. Yeah. So to sort of start out with this, since Cal 2 used to be a prereq for this class, and it's not anymore, so we're just gonna write down a couple of functions. It's certainly not any linear algebra functions. Okay, so functions that you might know, let's go with f of x is x squared plus 1.
Ellen?
Another function that you maybe don't know if you haven't had Cal 3, multivariable function here, f of xy is x squared plus y squared.
Oh.
Calculus problem, maybe sine squared x over sine 2x. Just examples, these are functions that you know. I am going to ask you a question now before I start this next discussion. So remember when we were talking about odd numbers, odd integers, they look like this, right?
Yes.
So let's just like say I'm making this a function my function is f of x equals 2x plus 1. Yeah.
Sure.
If I'm just talking about integers, what are the things that, stupid question, what are the things I'm plugging in? Right, okay, so this thing where we're starting, these are integers, right? And this function is mapping from the integers into what kind of numbers? Right, in general, what kind of numbers are they? They're real numbers, be more specific. Yeah, they're also integers, right? Yeah. And specifically, they're the odd ones, right? Yeah,
Yes.
Yeah.
Yes.
okay, this thing, domain, you know the domain, you're good, right? We can't call this the real numbers because we need everything, we need to, well, if we're talking about this being, whatever. Everything you plug in goes here, this is the domain of your function. This thing over here is the codomain, which is different than the range. This is the range. Tracking that? So I don't know that you have ever in your life called something a codomain. You have probably not. But a function maps from a domain into a codomain. Inside of that codomain, a subset, which is why we did subsets. Inside of that codomain, a subset of it is the actual range. Okay, if these are equivalent, it's a certain kind of function. We'll talk about that later. Okay, good. All right, so here we have this thing, x and y are non-empty sets. In our case, they're both integers on this example. A function f from x to y, which is written like this. This is a function defined from x to y. Good. This is your domain and your codomain. Yeah. Is an assignment of exactly one element of y to each element of x. So f of x equals y. This should look familiar to you, yes? Every input has exactly one output. Yeah, that's function. We good? All right, so the domain is your set x, which is called A here. Let's change that to an x. Your domain is the set x here. Your codomain is the set y that it maps into. This is a mapping. A function is a mapping. So this is your mapping or your function f. This is an x. This is the y. So if f of x equals y, y'all, then y is the image of x. So the image of x is y, the thing that the x is looking at under this mapping. Yeah? Are you with me? The image of x under this function is the thing it maps to, it's y. Yeah? Okay. The pre-image goes the other way. So the pre-image of y is x. Okay. Some people are also going to call this the inverse image. That's me. I'm some people. Hi. So the range or the image of everything in F, so this is the collection of all of the images, is right, it's the set of all the images of the elements in X. So there's a lot of symbols here, y'all don't be overwhelmed by that. But the range is the actual things that got mapped to. So like in our example, the range is the odds. That's going to be the only things that your answers actually are, right? So your range is actually sitting inside of the codomain. That's your range. It's the collection of things that actually that have an X, a pre-image in the domain. So the image of X, this is also called the range, y'all, of the set X is the set of all Y and Y. Let me read this to you. The set of all Y and Y such that there exists an X and X where f of X equals Y. That's a lot of words, a lot of letters, but it's the set of all y that have an x that got mapped to them. Yeah? So it's the set of all of the things, so in this case, it's all of the odd numbers, yeah? If you're talking about x squared, right, the range is all of the non-negative real numbers, yeah? Yes? Yeah, okay. The inverse image or the pre-image of an element. Y and Y is a set. Oh yeah, the set of things that map to it, because it's a function could have many things that map to the same thing. Okay, so the inverse image of an element is the set of elements that map to it. So in this case, let me draw an example maybe. Oh, I wrote down these things. These are nice. This is the set of, for the image, it's the set of output values. And for the inverse image, this is all input values that map to Y. Again, that mapping is the function that tells where something where to go. So if we're looking at, I don't know, 1, 2, 3, 4, 5, 6. So in our example here, the image of the set X is just B, the set containing B. It's a set of output values under this function. And then the inverse image of B is the set 1, 2, 3. Everything that got mapped to B. Does that make sense? How these sort of like go together. The image of X is everything that got mapped to. So in this case, only B. And then the inverse image is everything that was looking at B.
What's the symbol when you say inverse image?
That's just, there's no symbol, it's just me writing it. Of B is what that said.
Well, yeah, I was just wondering if.
There is
they
not.
have to find out.
No, there's no symbol that I know of. Well, we'll use it inverse notation, but not yet. Because we don't know that it will have an inverse, so we can't yet. Yeah. Okay, so some questions to help with Ruth, what time is it?
317.
Yeah, we can stop. No, we shouldn't stop. Sorry. That was really bad. Given an element X and X, how many elements of Y can be the image of X? So you have an X, how many Y's can it map to? Just one, that's what makes a function a function, yeah? Every input has exactly one output. Can there exist an element of an X that has no image in Y?
No.
No. Every X maps somewhere under these rules. For it to be the domain, there's not extra stuff there. In an actual domain, it's everything that gets mapped somewhere. So can there exist an element X that with an image outside of Y?
Yes.
Y is the codomain. So no.
Oh,
The the range, which is the, image, the collection of all the images, is sitting inside of the codomain. So it's always going to be in the codomain. Different question, opposite way. Can there exist a Y that has no pre-image in X?
Yes.
Yeah, again, because the range is a subset of the codomain, so there could be extra stuff in the codomain, like this. Right, we have half the stuff that's in the codomain that's not actually in the range, yeah? So there are, so none of the even numbers over here have pre-images, because they don't, nothing maps to them, right? Okay, so given an element Y, how many elements of X can be the pre-image of Y? How many things can map to a Y? All of them, any of them, all of them, right? However many there are. There are rules about how many, that X's can only go to one Y, and X can't go to two different Ys, but a whole bunch of X's can go to the same Y. Yeah, I got it. I did it. This picture, it's this picture that all of the X's go. Okay. We'll do more of that on Thursday. Again, your chapter 6 written homeworks due Friday, sorry, before I leave campus. Should come to class with questions on Thursday. Homework 7, yes, chapter 6, y'all didn't have to take the test last week. Oh, I was right. Whatever you want to know, I was right, I remember.
Are you just scared to say it?
No, well, I was scared if I was lower than it was, I didn't want, I didn't want to be rude about what Yes, I actually had to show that because you were having a difficult time. You were. No, you did great.
I was like, I didn't feel that good about it, but I was like, at least I wrote something down. for the
Yeah.
evening.
Yeah.
So then I saw it on the same day, I was like, okay, at least I didn't decrease.
Okay, here are some of the other things I've been holding on to that I want to longer hold on to. I graded that one maybe online, I don't know. You have a grade for it, so I don't know why there's nothing. But, oh.
The same thing on that too. That sucks. Oh.
Cool. I'll see y'all on Thursday.